2, 3. Recording very well. Okay, so good morning for everyone. We are in the part 5, I think, of Python for Dummies, and today we're finally arriving to conditions. I assume that you already kind of like know very well all the previous things that we spoke about, which was not very much. But we kind of repeated ourselves all the time. So, but I never did touch the conditions yet, and that's what we're going to do today. I will give examples how you're using conditions, and then another thing that I would like to do is probably to show how you can save Python script inside of Gizmo or group, so you will be able to reuse it. And then, if we'll make it, we'll also make the same script, save it inside of your Python directory, and then you will be able to update this Python script so everybody else in the company will be able to have it updated immediately. But that's kind of like, this is the plan. Let's start from the very, very basic, like dry explanation on the conditions. So the condition is basically, it's when you're saying if something is like that or like that and like that, do this and that and that and that. Okay, so if you will give me an apple, I will give you money. If your apple is red, put this apple on the table. If. So conditions is one of the cores, the core parts of any code that you can imagine. Okay, so let's start from very simple syntax. Let's imagine, not imagine, we have a list. Okay, that's something that we learned in previous. That's the list. So in list we have 1, 2, 3, 4, 5, which is inits. Okay, that's how we're storing the information. 1, 2, 3, 4, 5. Then we have one mama, which is a string. So you see it's inside of these little quotes. And then we have 3.2, which is a float, because there is a dot, so you know that this is not init, it's a float. Okay, so this is a little reminder on the types of information we can store. We can store like also inside of the list another list, which is something that, for example, it will be FFF, RRR. Okay, so you see one of the member of the list is list as well. Okay, so I'm stepping back a little bit to what we learned already. Okay, so for now I will go and I will create a loop. Okay, so I want to go through this list, and then we will create a condition. So first of all, let's create a loop as a reminder of loops that we did previously. And loop is going like that. The syntax is for member of the list, and this is opala without space. This is basically for whatever you will write. Right now I wrote member of the list, but basically let's call it just some, doesn't matter. Okay, in my list. So go through the each member, each item of the list and do nothing. And right now we're going to say print, and I will do already proper syntax, some. Okay, so now we're defining the list, then we're saying for any member of the list, print the member. Okay, so what's happening, he's go to the first member, he will print it. Then he will go back up, he will go to the second member, print it, and so on and so on and so on. So let's see if it will work. Boom. Okay, look at this magic. So you see result, he printed first one, then they printed second, and so on and so on. So we printed members of the list. Now let's start with conditions. Okay, so right now we're not going to print anymore, so we'll be not confused with the output there. But now let's create a condition. If something is corresponding to this member of the list, do something. For example, if sum equal 1, print hurrah. So now let's see what's happening. So first of all, you're learning now one of the members of condition that you can create is equal. And as you can see, it's not one equal, it's two of them. When you're writing one equal, meaning you have a variable and then you say this variable is that. But when you're writing two of them, this is part of the all members of the conditions. And let's learn them. First of all, it's equals. It's A equal B. Second one, which is also very important, is not equal. A, an exclamation mark, equal, meaning not equal B. That's another condition. Next one, it will be less. That's something that, I mean, probably you remember that from the school. I mean, the less and more. And for example, if A less or equal B, and then if A bigger than B, and if A more or equal B. Okay, that's the all conditions that we can have, and we will get to some additional stuff. So, but right now, very simple. If sum equal 1, print hurrah. Okay, so again, I'm selecting this, and as you can see, our result is hurrah, meaning one of our members actually equal 1. We found that there is a 1 which is 1. We also can say print sum. If I will print sum, what will it be? It will be 1, because we know that it's equal 1. So both examples are pretty basic and pretty kind of like, well, of course. Okay, but this is one of the conditions that we already managed to create. Now let's make it a little bit more interesting, and we will add additional things. And there is a few additional things like or, and, maybe something else. Let me see. Or, and, not. Just give me a second, because I'm pretty sure that I have it here. So that's equal, and that will be somewhere here. Example, or, okay. Nested or, and let's stay to this. There's also not somewhere. But basically, you can say few conditions. For example, if sum equal 1 or sum equal mama. And as I can see, I'm always taking care that I'm actually presenting the string. Okay? Print hurrah. And I will again go and execute that. So, first of all, hurrah, we found it. Then we print 1. And then hurrah, we found mama. Okay? So, we managed to do something because condition was met. Okay, very simple, and it's kind of like very simple to operate with that. And you can also add and here, for example, and sum. And now let's go a little bit more interesting. And type sum. Just a second, equal init, int, print hurrah. Okay, so I did add now, so I know that is like Alexey, what the fuck? But that will be the most complicated probably. So now I'm saying if sum is equal 1 or sum is equal mama, and additionally to that, type of this item is init, only then print hurrah and print sum. Okay, so in this case it will print hurrah only when the type of when this condition is met and this condition is met. Only then he will say found it. Okay, and in this case I will just go execute it, and as you can see he printed only one time hurrah because he found it when it's equal to 1. He also found when it's equal to mama, but mama actually is not init. Mama is a string. Okay, stop me if I'm running too fast. Also tell me, Alexey, yalla, next, if I'm running too slow. Okay, so this is very dry presentation of conditions, and it's very basic. Like I'm showing you very basic thing, but right now we will dive inside of the script and we will see how we can, or how you actually operate on conditions, and you doing this on, you going to do it or whatever. I'm doing this like on every single script, whatever script I will open, I will do it. So this is, for example, one of the scripts that I have at home in which I creating GIFs. Okay, so and there are millions of stuff that I did there. Okay, and it's kind of mess. So each one is GIF, creation of the GIF. And then I was thinking about example. Some time ago, I changed the location inside of which I want to render my GIFs. And right now, I want to fix it. So right now, my destination here is inside of mine. That's the folder when I'm writing to. Okay, but actually, my new location will be mine GIFs. And then slash. Okay, and I need to update this inside of all the write nodes that I have. Okay, so right now we have a mission, and our mission is to find all the write nodes inside of our node graph. Inside of these write nodes, to find the knob that we want to operate on, and then we want to operate on the string inside of this knob and change the string destination. Okay, so this is kind of like something, most of it we already did in the previous lessons when we went through the all nodes and stuff, and now we're adding to that conditions. So we'll say if, and you will see very fast. Okay, so let's start one by one. And if someone want to tell me how I'm going to start, from what, please don't be shy. We are only 6 people here, which makes it pretty much private lesson, and that's why we absolutely can just turn on the microphones and work together. So, who will tell me what will be my first line? All right.
So
yes,
maybe I chime in.
Go for it.
So from the logic here, we need to collect. If I understood you correctly, we need to collect all the write nodes first.
Exactly.
So we need to. I guess since we are not selecting anything, it would be nuke all nodes, and then we can filter that by write nodes. Sorry.
All right. So absolutely correctly. So first of all, we want to assign a variable to it because we don't want to repeat this all the time. So I will say all nodes equal. So I create a variable which called all nodes, and I assign my nuke all nodes to this variable. Now, what Igor mentioned, that you can actually already create a filter here that actually what he will do, if the node class is not right, he will not collect it and not add it to this list. But let's remove it right now. So we'll keep it very pure. So all nodes, will be nuke all nodes. Okay, so right now we have this variable. And now let's try to collect from this variable all write nodes, because we're interested in write nodes. And what previously Igor said, this is the filter that you can set and you should set. But right now I want to create a condition, and I want to collect all the write nodes with a different way. Okay, so I will say, I will iterate now through the list of all nodes, and I will ask, is this node write node? In this case, please add this node to the list of write nodes. Okay, now I say, please add this node to the list of write nodes. But we don't have list of write nodes, okay? And with the lists, you have to first create it. So I will say write nodes, of course, write nodes equal empty list. So you see here, I defined it empty list. Now I can erase this already. We don't want it, so it will be clean. Write nodes is empty list. Okay, so you see in beginning, mostly in code, you will define your stuff. And then all nodes and nuke all nodes. And now let's create our first condition. So let's iterate through all the nodes. We'll say for one, I usually make it one, in all nodes. And now condition, if one class equal write nodes. Now we want to, if he will find write node, we want that this write node will be added to the write nodes list. And the append we learned already previously. We will write write node. Write nodes dot append 1. So let's check this out. For 1 in all nodes, if this guy is right node, add this guy to the list called right nodes. Okay, now I will exit this loop and I will print it. Print right. No, I will get there. Right nodes. Boom. Okay, check this out. So right now we successfully collected all the right nodes. Okay, great. So that was our first condition. Now, what is our next thing? So we now have these right nodes. Our next step, we want to go inside of each of these right nodes, and we want to, inside of this right node, we want to access specific knob and change something inside of this knob. So when I'm saying we need to go inside of each, you already understand, okay, we need to create a loop, because loop is basically what it does. Kind of like what it does. You're going for each item inside of certain list. Okay, we need to create loop. So right now we have our right nodes, and now I will go for 1 in right nodes, and I'm kind of a little bit responsible for that because I'm giving the same variable here for 1 in all nodes, and here I'm giving same variable. Well, never kind of like made problems for me, but maybe it's not a great idea, because it's kind of like he's going for one member of this list. Okay, so we'll go for 1 in right nodes, and now what we need to do, and that's the rabbit hole kind of. Now we need to iterate and find specific knob name. Okay, and this knob name is if I will hover, it's called destination. You see, I'm getting destination. So now I'm going inside of the right node, and I will say I need to iterate through all the knobs which existing in this node and find this specific knob. Meaning I need to create another loop that will go through all the knobs, and then if name of this knob will be destination, do something to this knob. So you see, we're going into another loop, and this time we're already giving another condition. So we will say for 1 in right nodes, and I'm going to another loop immediately. For knob, let's say it now, knob, in 1 knobs. And this is function that will give me back all the knobs of the specific node. Okay, so you see, I'm going through every right node. You know what? I will call it right, so you will be less confused. For right in right nodes, I'm going inside of this right node, and then inside of this right node, I'm making another loop for knob in the right knobs, and here we're going for condition. If knob equal destination, print, and here we can already print the value of this knob. Okay, that's simple. Okay, so we say print, and that will be right knob dot value. Maybe I'm making some mistake there, but we'll be there very fast. Let me execute. Ha, look at that, did work. Surprise, surprise. Okay, I'm really surprised I didn't fuck it up. Okay, so now let's read it again. Okay, because here this is already kind of like pretty much starting to be kind of complicated a little bit. But let's go one by one again. Okay, so we did define the right nodes as a list. Okay, all the right nodes are here. List is empty. Then we collected here and defined as a variable all nodes which existing in this Nuke script. All nodes is Nuke all nodes. Okay, Nuke is the module in which we have function called all nodes, and this function is returning to us list of the all nodes of the Nuke. And then we're going and iterate for every node inside of the all nodes and creating condition. If class of this node equal write nodes append this node, which is 1 basically. Okay, so in beginning write node is going to be empty. And by the way, I can here show you how it's actually built. Print write nodes. So right now, if I will execute that, what will happen every time when he will append additional node to the list of the write nodes, I will ask him, print me this list now. And you will see it will look like a nice tree. Okay, it will look less nice tree, but you will see in beginning, because it's very fast starting to be very big tree, here. So check this out. He went through the first node that he found and he printed it. And he printed the list. Then he found next one and he added it and printed list, and it becoming bigger and bigger and bigger. So that's how he's iterating. Okay, but of course you don't want to print it. That's kind of like just stupid a little bit. So I don't want to print it here. But then we found all the write nodes. And now inside of write nodes, we're saying for every write inside of write nodes, do the loop. Inside of the write node, go for every knob inside of this write knob knobs. And if this knob named destination, print the value of this knob. Now let's make it more simple, because I can see that I went a little bit too complicated here. So first of all, this is simple. For one write node inside of the write nodes. Now go and do operation on the knobs. But here I can say, well, I can define this as a variable. V knobs. I can say v knobs equal variable write knob. So you see now, so I will kind of like say, go to every write nodes, and then his write knobs will be just a variable named v knobs, will be kind of write knobs, and then it's kind of easy to read. For every knob inside of write knobs of this write, if knob is destination, print this. Okay, I mean not more simple, but forget about it.
Can I just add to this?
Yeah.
That just what you mentioned with the how you call the for one in all nodes or for knob in W nodes, knobs. It is always good to name it as clear as possible.
Yeah.
So, or that you name it always the same. So like for one in all nodes is okay, but if other people have to read it, or you read it like after 3 weeks, if you write for node in all nodes, for write in write nodes, it is pretty clear what you read, and it's important. Because in the moment you are in there and you know it, but if you are writing it out and you come back to it later, you can, like Alexey just said, it is easy to read, and this is always a goal, that you write something that is easy to read. Just wanted to add to that.
Thank you. Okay, but now let's do the actual business, because our actual business was to create different path. Okay, we can just for now we can just replace this path of destination. Okay, but now it is very simple. So let's see. For every knob inside of all knobs, if the name of the knob is destination, let's do something. Right now we just did print this knob, but we basically can just replace the path. So the path was this one, Control C, but now we will give another one. We will say write, and then what was it? Knob, which is the name, or actually we also can say destination, because we know that knob is definitely equal destination. It will be the same thing, but let's make destination, because it's kind of like will be very clear for you what I'm doing. I'm going to the node that we're iterating through because we're going for every write, and this will be the write destination, and then set value, and then you can copy, invent whatever value you want, and in this case it's string, and we'll say a new location. Okay, and now let's execute, and let's see if this guy will change actually. Okay, so I'm selecting nothing, and then I'm executing the code, and as you can see, now the path inside of the right node is new location. And if I will go to every one of them, the path will be new location. Okay? So this is an example of how you using the loops and conditions inside of the script. I can give you more examples, and all of them will do very similar thing. You're going, you're looking, you're adding some, you're looking for some pattern, and if you're saying if the condition of this pattern is met, you're executing something. Okay? Now, are there questions so far?
Just one thing. Can you hear me?
Yeah.
In that part, could you jump, for example, because you're saying already for right nodes, Nuke knows already that the destination gonna be inside of the right node. Could you jump that second line and then go, or the second and the third, and then go directly to if knob is equal destination? Because he's gonna look for anyways the destination, right?
For right nodes, right node for knob, if knob equal destination. Yeah. Okay. So I will. What is the knob? That's why you can. So there is not such a thing as no. So knob is the variable that I created. So first of all, you need to look inside of all the knobs of this right node, and that's what you do. So let's print it. Okay. So let's print all knobs. So let's make something. Let's make another one. So more clear, basically. Version of the how iterating through the knobs. Okay, so
because I understand the methodology that you go step by step, saying if this you have that, and if that you get that. But then, as Nuke already knows that destination is inside of right knob.
Yes.
Or the node, you could simplify that just to jump exactly on that point and then give me this.
No, okay, let's do it again, and then you will understand why you can't do that. Okay, so we have one node. In this case, like let's go with one node. It's Blair. It's simple. It doesn't have. Let's go for no op. No op. Simple node. I can answer you as well, but I'll kind of like I will just go now, and we will just go through again loop and so on. Okay, so we'll say no op equal nuke selected node. You can press. Tab and then say selected node. Okay, so right now we define this no op as nuke selected node. Now you pretty like let's go and access label. Okay, so how will you access label now?
Good question.
No, that's simple basically. You want to access label, you want to just say nope, and then you will say label, set value, blah blah blah. What I'm doing, idiot. Sorry. I was thinking about something else while I'm writing blah 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 blah. Okay, so simple. Okay, did work. Okay, now let's try to access something that maybe not existing there, and we'll say nope, disable for example, and that's what you're proposing. Set value 1. That's what you're proposing. You're saying, well, Alexey, you know that there's destination inside of your write node. Well, maybe yes, maybe not. Destination is knob, which I created. It's inside of write nodes. There's now no knob named destination because that's something that I created, and you cannot assume that it's there. So right now I'm assuming that disable is there, and now if I will execute this, I will get an error. Line 3, knob disable does not exist. And that's why you want, first of all, check, in order to not get inside of the error, you want to check, is there this knob? If there is this knob, meaning that Alexey knows that this knob is there, and Alexey probably created this. So this is your safety net before you go into error, okay? What you can do something that I'm doing a lot, generally in my code. It's try, accept, and programmers will tell you all the time, don't do it, and I'm also telling you try not to do it. Accept. So basically, he will tell you what try accepted does. It's a reasonable thing in programming basically, but basically I will explain you the problem with that. Try to set the value. If you will have an error, just pass, just keep going, and then I will say keep going executing the code. For example, print who cares, meaning no error will be executed. Look at this, enter, nothing happened, he printed who cares. The problem with the try except that by default it does not print the error that's happened while you execute it. He will just swallow it, he will just like, didn't find, whatever, let's keep going, pass. Okay, that's why programmers asking don't use try except, try to go check if condition could be met, execute the code, otherwise stop and print the message. For example, try except, you can also say except print and then unfortunately you don't know what is the error. I mean, there is a trace back and stuff, but now when it says there was an error, for example. Or I can say instead of print, let's learn something simple, nuke message. And now I will execute it. There will be message. He will tell me, dude, something happened, and he's writing you and then he will say okay, and he will keep going, and then he will say who cares. Okay, so he kept running through the code. Okay, Salvador.
Hello.
Hello.
Yeah, I had a question. I forgot. Yes. So when you put the last line, right? Destination set value. Then
Yes.
that means that the new location path, you
Yes.
have to create this folder previously, otherwise what happens?
Yeah, so this is a different workshop, it's not. No, what it does, it's basically, this is my write note. What it does is just put this string inside. Completely, that's the fun part of programming. There's no magic, never. It's just doing what you're telling him to do. Go there, put this destination inside of this. Now, here I have a knob called create GIF, and we can have a look now together. That can be fun. Let's read what this code is doing. So this is the Python code, and we have still 25 minutes, and we probably can learn now how to add Python buttons to the nodes. Okay, so first of all, let's read this button, and to do that, I can use just script editor. There's knob scripter. Okay, it's I can just pick it up, but since not all of you have knob scripter, I will just use the native kind of tools. I can go manage user knobs and then create GIF, and I will make edit. And now you will see the code that is written here. And now you can read this code, and also you can create this code. Now let's read this. Let me copy this because it's too little. And I will close it right now. Yeah, close it. And I'll just paste it here, and we'll try to understand what this code is doing. Okay, so import OS, and meaning please import module of operating system. It's answering your question about creating the folders. If you want to create folders, you have to use OS module, because OS module has functions which creating folder in the system. Okay, Nuke by itself cannot do it. But then let's have a look on the code, which is extremely simple. So first I'm defining a variable nuke this node. You remember the selected node? When you're using the Python command from inside of the node, you don't want to use selected node, because selected node can be any node selected in your tree. Every button in the right node, render for example, this is a native button. It also will use nuke this node, meaning node in which button was pressed. Okay, so a equal nuke this node. Okay, now we have one node now, and this is the node. Then go to the button called render and execute it. Okay, so how I'm creating the GIF. So first of all, I'm going to my node, then I'm rendering the material, whatever he's supposed to render. And I'm reading now with you like a book. Okay, material rendered. After I executed this render, I'm collecting destination path, and that's will be A, which is this node, destination knob value. I'm collecting the value of the path. Then I'm defining the name, probably that GIF will get, and this is, I'm going to this node and going to gname. Let's see what is my gname, and probably it's this gname, GIF name, and collecting the value of this knob. Then I'm collecting value of the loop knob. I don't know what it does, but probably later we need it. Then I'm collecting value of the delay, which is here. Now, all this is just, I'm going and collecting value in all these knobs. Very simple, okay, same. And then I'm collecting the path. So I don't know what is this, but let's read it. I'm going to the file knob, which is here, and I'm collecting the path. Now there is a value or evaluate. Okay, now evaluate, just for you, you don't have to remember that. Instead of collect a value, you writing evaluate. What it does, if there is an expression, which I do have here inside of my file, I have no idea why, but whatever, I have it. He will first evaluate an expression, because here I can see there's TCL. And then whatever the result of this expression, he will give me this as a string, okay? And then I'm applying some R partition, which you absolutely don't care right now. We can talk about this later in the next workshop or something, because that's also important. But basically, I'm getting the path. And then I'm defining the string in the end. So, and that's going to be one long text. Okay, what is this guy? It's basically what is that's the string that I'm going to execute with the OS system in the end. Okay, so this part is black magic, because this is the converter of the material that I did render to GIF. Okay, and I kind of like found this converter and outside, and then I was like, well, if I have this command and OS system can execute this command, I can just give to this command all the variables that I just collected. Here, you see, now we have this delay, the loop, the path, destination name, and the name. And after I'm collecting all this inside of one string, I'm getting them, I'm executing this, and I'm creating a GIF. Extremely simple. Okay, so that's the Python command that I'm executing in my knob. So far, questions about that? Don't ask me about this, because that's kind of like out of the scope right now. But I don't think that you have some questions about what I'm doing in all this part of them, right?
Just the import OS. That means that you have another script with the OS information inside your.
No, import OS. So every Linux will have OS. I think every operation system basically. But let's print OS. So print. Let's have a look what OS is giving to us. What OS has inside, which modules, I don't know, functions or whatever. Print dir OS. And that's very useful. You can do it with everything, with Nuke, this node, selected on whatever. So I will just select this because I already imported OS, but let's go import OS, print dir OS, boom. And here, everything that you can do with OS. For example, the first one that my eye is catching here, list directory, list dir. Meaning I can with OS give the directory, and then when I'm executing list dir, he will give me a list of everything which is inside of this directory, and that's how you're iterating through the files, okay? And you can, whatever, you know, there's many things, most of them I don't know. Absolutely most of them, like 95%, but some little ones I know. And that's a print dir of something, it's extremely helpful. For example, nuke this node, print dir meaning what is inside of this box. Okay, so nuke is one box. Inside of box there is this not box. What is inside of this guy? Let's print it. Let's have a look. And this is that's the part where you're having the most of fun. You can at home, whenever you're training Python, you can just say print what the node is actually can do. For example, set selected. You can say select this node specifically. So for example, you see this node, I will say selected node. Okay, and this is my or doesn't matter, you know, transform, who cares. So this guy, and now I will print what is inside of this node, and this will be this. So for example, X position, Y position, okay? Now, you also can see what X pose or Y pose doing by themselves. So for example, I can say Nuke selected node, and then X pose, print. So right now, is actually, we're going to the Nuke inside of selected node, inside of the knob called X pose. Let's see what this node can give us. You can make it enabled, set expression, set flag, or whatever. Usually with the X position, you can just set position of this knob. So for example, I can say select the node, X pose, set value, 5,000 or 500. Okay, it will fly somewhere right now, but you see it's somewhere in position 5,000. Okay, so I threw it, I did blast it away. Okay, but very important thing is that this dir because it's just telling you what you can do actually with a certain box. Doesn't matter what it's like. What you can do with the nuke if I is equal nuke. What you can do with the selected nodes if I is equal selected nodes. Is it understandable? This is information from our very first workshop, but it's so crucial. I'm using this so much because it's so helpful. There's also one called, I think, help. I didn't use it. Let me. Which is also you see it's extremely important or extremely helpful. So basically, instead of printing all the functions or modules that you have inside, you can just print the help on the level of certain on a certain level. Okay, so I'm defining the and I'm saying, well, help me. What can I do with this guy? For example, set visible, and then he's explaining to you a little bit about that. The explanations are usually quite very not for dummies. So basically you need to understand, but generally it's not so bad. Height. What is returning? It's returning height of the values, okay? And that's important. What is returning? This has its expression. For example, you can check if specific knob has expression, okay? What it will return? It will return you true if there is expression, false otherwise. True and false we did learn previously. Okay, so now I'm more kind of like diving to give you a little bit more overview, and now let's just, after this kind of going left a little bit to overviews, we did touch conditions today, we did touch heavily loops as in the previous workshop as well. Now let's create Python button inside of the node, okay, of the Python script. So first of all, we have already Python script here, which is quite long. It's this guy. Okay, what this Python script will do, he will just let me destination set value, this guy. It will go through all the write nodes and it will set certain value to certain knob. Okay, so now let's create a controller knob. I will take no op because it's kind of empty. And now let's add a Python knob there. And inside of this Python knob, we will add this Nuke script. So we will be able to reuse it. Okay, so I'll say right click, manage user. Actually, where is the, I don't have properties, just a second. Because there's like from Nuke 12 already, there's the new properties, which I'm using all the time. Not properties, just get to properties. It's funny. Yeah, show tabs. Come on, I don't have time for that. No. Properties, why I have two of them? You know what I'm looking for, right? The official properties, sorry. Okay, this guy. So, you have this little one, and I'm pretty sure you used it a lot. Tell me if you didn't.
Bad face.
I don't see you guys. I'm presenting. I'm basically talking to myself right now on the screen, so I need to hear. Anyway, then I will explain you very fast. So this guy is helping you to add knobs and so on and so on. That's super useful. Okay, so go to no ops, double click, and then I will add the Python. This is the Python knob. Drag, drop, simple. And then you can name it. Let's name it. Okay, let's say this will be the official name of that, and we will say test button. And this will be the label. And label will be test button. Okay, and here we will add the script, which I will copy from here, Control C and Control V. Now, done. Boom. What we would expect right now that this test button will go and we will add the new name to all these guys. So this is my write node, and I will just erase the name here, and I will test my button. I will click the test button. Boom, did work. Congratulations, we managed to add now Python script inside of the Python, inside of the knob. Let's go a little bit fancier, because right now what's happening, we can add only this one text. But we can say, well, let's be able to define our text here. Let's create a knob, string knob, which will be not float. This is float, integer. I will find it. Text, I guess this guy. No, not this one. This text. Okay. And then we will call it new pass. New pass, that will be the name, and new pass, that will be the label. Okay, so what I'm trying to do right now, I want to type new pass here, and I want to set this any pass that I want, and then just execute this button. So he will collect my pass and then add it to all the other nodes. Simple, right? Tell me if you're losing me. I like, you know, I prefer to...
Simple, yes.
It's fine, yeah.
All right, thank you very much. I like, you know, don't tell me after like 50 minutes, Alexey, I didn't understand you. Because I can go back. It's like, you know, it's not hard to go back. Okay, good. So what we need to do, we need to rewrite this code, test button code, so he will go here and collect this pass. Okay, so let's rewrite it. I don't like to rewrite it inside of this little window, because it's not fun. So you can do it there. But since I have knob scripter from Adrian Pueyo, I can just select my node, and I can pick it here. Pick. And then I can go to the test button, and here is my code, okay? And this is like a lot of fun, because, well, that's kind of like good knob scripter, okay? So let's see what we have here. So here we have hard-coded the value that we're setting. But instead of have it hard-coded, we can say, go to this node, collect this value, and then put it here. Very simple. That's something that we learned already. So I will go here and I will say nuke this node, ntn equal nuke this node. Okay. And then that was the first thing that you can make it in one line, everything, but it will be easier for you if you want to extend your code later, that you will be very specific what you're setting. So ntn, it's nuke this node, but actually I want this guy, which is new path. And path equal, and now somebody will tell me the new path, how I'm collecting
New path, knob.
ntn new path and
dot value.
Thank you very much. Okay, so now we have the variable. So basically he will go inside of the same node that we're executing, collect the value of specific knob, and now we can say take this variable and set it here. Easy. Okay, now let's check if it does work. So first of all, I need to save it. Okay, so right now it's saved inside of this no op. And let's check this out. Test button, execute, boom. Let's make different. Execute, bam, different. Execute, different. Execute. And this is the power of programming. In very, very beginning, you're very slow. You don't know why you need it. You know that you can do it simple by just going and changing the values. But from the moment you have right now, like here, you have like 50 write nodes, and you can just going and in one controller that you set, and you can change it. Very similar. That's why I have massive panel that I kind of using a lot, because I can easily go through it. That's what massive panel is doing. Go through this node. If this condition is met, disable this node. If enable this node. If, and so on and so on. And this is very, 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 very basic code. And I'm very much encouraging you to try to create these little snippets that I did create right now. And
Just your presentation.
I'm now presenting this.
Okay.
I exited. Now it's the motivational speech time. So there's another thing that I would recommend you. There is a huge amount of Python snippets online. Again, I'm pointing you all the time to Andrea Jeremia. There is I saw on the LinkedIn, funny enough, yesterday, something from Gata Media. It's a Hungarian guy, which putting a lot of TCL stuff outside, and this is just gold. It's what is his name? Because I'm frequently going on his page. I will give you it right now. What is oh shit? I will find it. No, did you give me a second? Somebody remember that who I'm talking about? Expressions, Gati Media.
Yes, he released something new yesterday.
Yeah, yeah.
Big,
It's so I just
it's super good.
it's called Gati Media.
Uh-huh.
.co.uk.
I have it here. I will
Yeah,
share that.
this one. Just like for all the people that like found that it's maybe useful for them workshop like that I'm doing right now, which is like very much beginning. You're going there, and he has a lot of TCL, but now he released something about the Python, and that's exactly what we're talking about today. It's very basic. What is the loop? What is the condition? What is this? What is that? Very basic examples. I'm very much encouraging you try, challenge yourself to go and exactly this one. Power of iteration. That was very funny. I was like, that's exactly what I mean, I was talking about iteration last time. So, we are in 5 minutes before 10. Questions, suggestions, which is important because I'm kind of like kept going now with the Python because I don't have more ideas what to do. If there is some suggestions from your side, if you don't want to tell me right now, but you still think something, just please send me a message.
For the workshop, you mean? Or?
Yes, for the workshop, for the Python workshop, for TCL expressions or whatever. Whatever suggestions you can have, like next week, Salvador is doing. After next week, I don't know, I need to invent something again. And that's quite, the biggest problem is to actually to invent something that people would like to come and it will be useful for everyone.
After next week, most people are out anyways.
Maybe I will like John Oliver will go on holidays for Sylvester or something. Yes, and then new season. I think that can be a good idea. Salvador, no pressure. You're the last episode.
Finale.
Yeah, finale.
If nobody has any suggestions, can I just add something
Yep.
to what you did? I just want to real quick share, and maybe it's just a tip. Because when Alexey asked in the beginning, how do I start? And you were all quiet, might be because we are a quiet bunch. But usually what you don't come up with a script and you just go through it and you have that and you just, line 1, line 2, line 3. What helps if you start out, because this can be very intimidating, is, and especially in the beginning, the translation from code to what you want to do is a bit harder. Because Alexey knows all the stuff and he just can type it and translate it simultaneously, like he's fluent in another language. What helps is that you okay, Alexey wants to collect all nodes. Okay, cool. Then you just write down, we need collect all nodes. Then the next step, iterate if they are write nodes, and then you can really write it out. And because you write it out, you can then go line by line, and then create your code. But if you have basically you create a recipe what you have to do, and then you bake it.
Mm-hmm.
This is it seems abstract, but it's really helping a lot in the beginning, because then you don't get into the how do I, what do I, and then you just put it into words, and if you have it in words, you can translate it into code easier. Because if you have a question, then you can nearly like, how do I iterate through a list? You can just ask it because you already wrote it down. Yeah, just so as a structure idea for you, maybe to have an idea how to tackle code in the beginning.
Yeah, and I will add to that that it's not just beginning. It's crucial. Unfortunately, I cannot find it, but my code usually starting from me sitting with the paper, like literally, and making cubics. Like I'm sitting with the paper and I'm starting with like, okay, this cube, that will be first step. Then I'm making error. Then I will go through this. Then I'm making error. Then I go to this, because every code as a language as well is it's basically, it's the code itself. It's very, like, it's 30%, it's 10% of the thing. If you have good idea, and then if you're managing to make good logic out of this idea, the code itself is it's a marginal. It's very, very marginal. That's kind of like, and that's what Igor is showing here. Just write your idea down, be sure that logic is working. To translate it to code is the last 10%. Even in very beginning, it's annoying. You need to go to Google, why I'm failing, why I'm collecting right thing. But Google is full of, like, I love Google again. I'm like, it's made for dummies. You're just writing my code not working, and then you're getting like billions of suggestions. You need to be more precise, But it's super simple. From the moment you have your logic, now we have to cut. I have to go to another meeting. Thank you very much for your time.
Just one addition. If you have your list, also it gives you the benefit that you can just basically comment it out. You can comment it out, because then if you comment it out, you already, like, here you can see my list I have. But if you basically write it into after that, you already have also documentation in there, like create recombined tree, and then okay, cool, or like selected reads, deeps, or appropriate anchors, and you already have documentation in your script, but you don't have to do it again, because in the end you want a script which is readable and to remember what you did there. Last thing. Thank you very much.
Yeah. Now I have to jump out. Okay.
Yeah.
Thanks. Ciao.
Bye.
Thank
Thank you,
you.
guys.
Bye bye.
Have a good day.
Bye-bye.
Stop recording. Stop recording. Where is my
Yeah, stop recording quick.
Yes.
Morning. Morning. Morning, 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 morning.
Morning. Where is my record? We have